On the surface of southern India, you find ancient, dark rock formations forged in volcanic fire. But just below the waves, the landscape shifts into vibrant, living networks of coral. These extremes were sculpted by the same geological forces. To understand the region, we have to look at the massive physical geometry that defines the bottom half of the subcontinent. This is the peninsular plateau. A peninsula is simply land surrounded by water on three sides, and here it takes the form of a vast triangle jutting deep into the Indian Ocean. This geometry dictates the local climate, the reach of the rivers, and the survival of every community across the plateau. It is the physical framework for everything that follows. This triangle wasn't shaped by slow erosion alone. Millions of years ago, this entire landmass was the site of violent volcanic activity. Massive flows of molten magma cooled and hardened over millennia. They stacked up into thick layers of the oldest, most rugged rock formations found on Earth. We can see the scale of this volcanic legacy in regions like Chota Nagpur. The intense heat and pressure of that ancient activity left behind a massive treasure trove of minerals, coal, iron, and manganese, trapped within the stone. This ancient geology is far from dead rock. It is the foundational blueprint providing raw materials and power for India's modern industrial economy. Guarding the edges of this plateau are the Ghats, mountain ranges that act as massive physical borders between the interior and the sea. On the west, the mountains form a towering, continuous wall stretching almost unbroken along the Arabian Sea. But the eastern Ghats are different. They are much lower and heavily fragmented, appearing as a series of broken hills. There's a reason for this. The plateau functions like a massive table, tilted slightly toward the east. This tilt forces major rivers to originate in the high west, flow across the landmass, and slice through gaps in the eastern hills to reach the sea. This combination of physical slope and mountain gaps creates the region's hydrological system, delivering the water required for millions of people to farm and live. In the northeast, geography forces even more radical adaptation. Here, the Meghalaya Plateau sits as a high-altitude geographic shelf. The shape of these hills acts as a funnel, catching moisture and creating one of the wettest places on the planet. This creates a constant crisis for building. In torrential rains, traditional wooden or stone bridges are frequently swept away by the force of the water. The living root bridges of Mawling Nong are an indigenous engineering solution to this geography. By weaving the roots of living trees across the river, builders create a structure that grows stronger and more stable as the forest matures. Humans cannot rely on static concrete in this environment. To survive here, they have adapted by using living biology as their infrastructure. As the plateau meets the sea, the land narrows. On the west coast, the plains are a thin, rocky drop-off, squeezed between the mountains and the ocean. Contrast that with the east coast. Here, the powerful rivers have spent millennia depositing sediment, building massive, fertile deltas that fan out toward the horizon. Beyond these coasts lie India's offshore archipelagos, scattered island territories with very different physical origins. Lakshadweep is a fragile ring, barely rising above sea level. It is built entirely of coral polyps, a biogenic landscape that relies on a delicate biological balance to exist. But the Andaman and Nicobar Islands were built by fire. These are the jagged, smoking peaks of a volcanic mountain range that remains hidden beneath the ocean's surface. These archipelagos show that the geography of the region is not a finished monument. It is a shifting footprint, built by both fragile marine life and active magma. From the ancient volcanic foundations of the south to the intense rainfall of the northeast, millions of years of geological pressure have shaped these landscapes. But whether it is a low-lying coral atoll or a silt-heavy delta, these environments are incredibly fragile. Modern expansion and shifting climates put these specific physical shapes at risk. To protect these zones, we must adapt our behavior just as the bridge builders did, by aligning our industries and tourism with the natural limits of the land. Understanding nature's blueprints is more than a mapping exercise. These physical shapes are the essential instruction manual for the sustainable survival of our civilization.